Good morning, good afternoon, and good evening, ladies and gentlemen. This is Glenn Tan speaking. This time, I'm going to talk about boost heating technology. This sharing is about the pros and cons for the boost heating technology. As I'm still working at GREE, I'm going to review which the product mainly in North American market applies this kind of the technology. And also during this sharing, I will show you how the refrigerant flow in the cycles. And also I will use the pH diagram to analyze. It will be a little bit complicated. This sharing divides into these 5 parts. First is the regular cycle. This is the basic of basic, which is this cycle including 4 components: the compressor, condenser, metering device like the electronic expansion valve, here short for EXV, and the evaporator. And below is the local pressure and enthalpy diagram. So first of all, from the compressor, this one, we compress the low pressure vapor into the high pressure and temperature, go to this one, and send this vapor into the condenser, just like this, to release heat. Then this is still the high pressure. After that, it will go to this point. That means it is already become the liquid. And we send this liquid to the metering device. This case is the EXV, and after metering, it will become the low pressure and temperature. Here is the gas and vapor mixture. Then we send this part to the evaporator to do cooling, which is to absorb heat. And here is still the low pressure. And after that, here is already the vapor. We send this vapor to the compressor for compressed. Next, we go to the first boost heating technology, liquid injection. This is the cycle diagram. And what is the difference to the regular? It is we add another EXV and also get the liquid refrigerant from here and inject this liquid into the compressor. So from the local pH diagram, we are going to analyze what is the benefit we can get from this injection. So first of all, we just inject from this liquid part, and then we cool down the compressor discharge. This part, make it to here. On the other hand, as we inject the liquid refrigerant, also we can higher the high pressure, make it to be a little bit higher. So the benefit is this one. We can have a lower compressor discharge temperature, and also we can higher the condensing pressure, which is also to higher the air discharge temperature of the heat pump. And for this one, especially for the number 1, we can ensure the system reliability to avoid the compressor to become overheat, which is very common in low temperature heating. That's all for this sharing. If you still have any other question, just feel free to contact me on my personal email address. Hasta la próxima. それではまた次回。